Okay, good morning, you guys. We are going to be talking about lesson 9.3 for Algebra 1, which is all about scatter plots and lines of best fit. Okay, so 9.3 learning targets would be calculate the line of best fit and analyze key features of the scatter plot based on given information. All right, so going down here, looking first right at scatter plot. For our example number 1, it says using the information below, answer the following questions with your table group. So Nicholas plotted data points to represent the relationship between screen size and the cost of television sets. Everything about televisions is the same except for the screen size. Okay, so you can see screen size over here. We've got 40, 42, 43, 48, 50, and then costs from $300 to $500, right? So then he's graphed those on the graph over here. Screen size is X, cost is Y, and we plotted those points, okay? Part A says, describe any patterns you see. Well, hopefully you're seeing that both of the values are going up together, right? So both values are increasing. So as the screen size gets bigger, the cost gets more and more expensive, right? That's pretty common. What does this set of points tell you about the relationship of screen size and the cost of the television? Well, that's kind of what we just said, right? The larger the screen, the more expensive it is. Okay, the larger the screen, the more it costs. Okay, then letter C, where do you think the point for a 46-inch television would be on the graph? How about a 60-inch TV? So 46-inch television. So if I go up here, right, you can kind of see if we just barely kind of go, this might be somewhat of a line that just kind of trends upward like this, right? So 46 is going to be probably somewhere right around here, like 420, 25, 435, something like that. And then a 60-inch television, of course, is going to keep on going up, 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 right? So this would be up top even further. So if we talk about maybe 52, 54, 56, 58, 60, right? And we keep going up to here, we're probably going to be in the $600 or $650 range. Okay, so 46-inch television, probably somewhere around like $425. And then 60-inch TV, probably somewhere around $600, $650. And we know that because it's kind of creating a straight line going up. So we're putting in that line to kind of create and estimate where we think those values might be. Okay. So there are different types of correlation or relationships between data. All right. And these three graphs here are showing you what those relationships are. This first one is going up, 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 up together, right? We kind of can draw a straight line like positive slope. And that's exactly what this is going to be, a positive correlation, because both X and Y are going up together, right? So just like the screen size, the bigger the screen, the more it costs, okay? Then the negative one comes next. So this one, as you can see, if I draw a line for the trend line here, they're all kind of going down together. Well, what happens is they're not both going down. The Y value is getting smaller and smaller and smaller, but the X value is actually going up, 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 up as they go across. So this is called a negative correlation because one goes up while the other one goes down. Okay, and specifically, the Y goes down as the X, I just wrote that backwards. The X goes up as the Y goes down. Okay? Then the last one, you can see all the points are just kind of everywhere, all right? And when they're scattered all around here, we just simply say that these really have no relationship. They don't follow any type of trend. There's nothing that's giving you some type of pattern to follow. So no relation, or in this case, correlation, right? So these are all about types of correlation. Okay, so you have positive, you have negative, and then you have none at all. Okay, so using that coming down here, we're going to try to make our lines of best fit. All right, so a line of best fit or a trend line models the data in a scatter plot by showing the general direction, okay, the general direction that they seem to be going, right? So just like that one, we were going up together, so it was like a positive line, down together, negative. A line of best fit is positioned so that it is as close to the middle of the data as possible. So you want it to be in the line as close as possible, okay? We can use an equation, okay? Use an equation for the line of the best fit to represent the data values on the graph. Now, that equation, right, you just saw me. I made a straight line going up like this, a straight line going down like this. So the only way to get those straight lines is to use a linear equation, which is our y equals mx plus b. So we're circling all the way back to the beginning of the year when we talked about writing equations of lines, okay? So we're thinking about slope for m, you're thinking about y-intercept for b. I'm talking and writing at the same time, you guys. So slope is m, and b equals the y-intercept, okay? All right, so coming down here, let's look at this first one. We're going to actually make a scatter plot by doing the data points, and then we're going to get our line of best fit, okay? So the table below shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? All right, so for this one, your internet speed is going to be your X values, okay? And the time to download would be the Y values, all right? So it's always X, Y, top, bottom. So it tells us to label the X and Y axis so we know what's happening, right? And we just said X is going to be the internet speed. So I'm going to come down here and put internet speed, okay? And then if you look up here again, Y is the time to download. So time to download, okay? And then we have number 2 says plot the points in the table, okay? Well, we're going to have to be able to label our intervals first. So when I'm looking at this, my X's are 35, 40, 45, 50. So I'm just going to count by fives. And I'm going to make a little kind of break in my graph to say that I'm going to start this guy with 30, and then 35, and then 40, and then 45, 50, 55, 60, 65. Okay. And then going the other way, we've got our smallest is 3.88 and it goes up to 6.65. So we could start like at 3 and we could go up by halves on that part. Okay. So we're going to be close but not exact. So I'm going to put another break over here and I'm going to do 3, 3.5, 4, 4.5, and just keep going. 5, 5.5, 6, 6.5, and then 7 and 7.5. Okay. So from here, all right, we're going to plot each of one of these points. So we've got this first one, X, Y would make a point this way. So I've got 35 and then 6.65. So over 35, up 6.65. There's my first one. And then 40, 5.82. So 45.82 would be almost a 6. Okay. 45 and 5.17. So just above our 5. Then we have 50 and 4.65. Okay. Then we've got 55 and 4.23. And 60 with 3.88. So 60 and almost to 4. Okay. All right. So then what we're going to do next in our checklist here is we're going to draw the trend line, okay? So the trend line is kind of on your, it's kind of on you to get it where it needs to be, but the thing is we have to have 2 points that our trend line goes through in order to make sure that we know 2 points for slope, okay? So if I have to pick my line here, I'm going to grab my shapes, okay? And my line, we're going to go somewhat in here. Kind of maybe through the middle of these as best I can. Kind of 3 on one side and 3 on the other, okay? All right, so you have to pick 2 points that your line goes through. So mine's going to start here at 0. Oops, I'm still on the thing, sorry. I'm going to start at 0 here, right? So I've got 0, 7.25 for my y. And then I've got a point that goes through here, which was that last one up here that we mentioned, 60, 3.88. Right? So we have to write an equation. So it says, write the equation of the line, find the 2 points, and we're going to use slope, right? So slope, remember, is y2 minus y1 over x2 minus x1. So I'm going to use that here. I've got 7.25 minus 3.88 over 60 minus 0, okay? I'm sorry, 0 minus 60. Goodness, you guys, I'm making a lot of mistakes. My fault, okay? 0 minus 60, so I have something over negative 60, and I'm going to type these in, and I've got 7.25 minus 3.88, and I get 3.37, and I'm going to go ahead and divide that because I can't have a decimal like that, so my slope ends up being negative 0.0, and I'm going to do 56, okay? Or I could do 0.06 if you wanted to as well. So there's my slope, okay? I need my y-intercept, which I have at 7.25 for my 0, all right? So I'm going to go ahead and write my equation. Y equals m, which is my negative 0.056, mx, plus b, which my b again was up there at my 0, so 7.25. Okay, now we're not all going to have the exact same every single time because our points are going to be different. Our lines are going to be a little bit different based on where we decide to put them. Okay, but everybody's should be pretty close. Like the first time I did this, I got negative 0.0549, right? So that's pretty darn close, and I got the exact same y-intercept. So again, they shouldn't be terribly off, but they are going to be a little bit different every time we do them, okay? And that's all right. Okay, so now you try this one, doing the exact same thing, following the steps above, pause the video, and then check and see if you got what I have, okay? All right, so I'm going to guide you through what I'm doing here. Hours of studying is going to be my X, and test scores are going to be my Y. All right, so I'm going to have hours down here. And then this is going to be my test scores. Okay, my hours go 6, 7, 8, and 9. So I'm just going to go ahead and do counting by ones here, right? So I'm going to have kind of a little break, and I'm just going to do 6, 7, 8, 9, and 10 just to make it easy. All right, and then my test scores go from 77 to 92. So I'm just going to count by twos. I'm going to do a little break here. 75, 77. Okay, then I'm going to plot my points. So 6 is 77. So over 6 up 77. Then I've got 780, which is here. And I've got 7 again at 83. Okay. Then we have 8 at 87. And we have 9 at 92. Oops, sorry. Get this done. 9 at 92. Okay. So then we need to make a line, right, that goes through. So I'm going to grab my line tool here, and I'm going to put in pretty darn close there. Okay. All right. So then for this one, my 2 points are those last 2 on the end that it went through. All right. So for me, those 2 points are going to be 887 and 992. Okay, so I'm going to do the same thing I did earlier. I'm going to take 92 minus 87 over 9 minus 8. Okay, 92 minus 87 is 5, right? And 5 over 1 equals 5. So my slope is 5. Now, my y-intercept is not as easily seen here because I did a break in my graph. So I'm going to have to solve for my b value. Okay, well, that's pretty easy. We're just going to take out what we have. So I have an x here, and I have a y, and I have y equals mx plus b. So I'm going to be able to plug in everything I need. My y is 87, m is 5, x is 8, and I'm going to solve for b. So then 87 equals 40 plus b. And if I subtract 40 over to the other side, I'm going to have 47 equals b. So my b and my m are going to make y equals 5x plus 47. Okay? Okay, so then the last part says, use your equation to predict your test score if you have studied for 3 hours. So 3 hours is x, so I'm going to use my equation, and I'm going to plug in 3 for x and figure out what my test score might be. So this would be 15 plus 47, and 15 plus 47 gives me 62. So if I only study for 3 hours, I'm still going to get a D. So better study for longer. All right. All right. So in summary, I can use a scatter plot to describe the relationship between 2 data sets by plotting the points, right? So plotting the points of the data. Okay. Then draw a line to the data and write an equation. I'm going to put here line of best fit because we want it to fit through the middle as best it can. And write a linear equation. Okay, so again, y equals mx plus b. Whoops, that one's kind of bad. All right, good job, you guys. If you have any questions, let us know. Okay.